And so as I walk around the room, I'm seeing, so far I've got 1, 2, 3. It's gone. Oh no, oh yeah. So 1, 2, 3, it's hidden. 1, 2, 3, 4. 4 different rectangular prisms that have been made. So if you're wondering what they might look like, just have a peek over there, because the next question is then, how many different rectangular prisms can you build using 32 cubes? Remembering that it is rectangular prisms. So is there going to be more than 4? 6? Yeah. Mm.
Is the orientation of the same shape important? Because theirs is exactly the same as ours. Ours is like down, theirs is vertical. Does
Yeah, oh no,
that
it's the same shape. It's the same shape.
Yeah, because you still describe it as being a 2 by 2 by.
Yeah, exactly.
But if you were to then transfer that onto a 2D piece of paper, that would work, wouldn't it? Because you'd be drawing it differently. Yeah. Yeah, but the dimensions would be the same. Yeah. Yeah.
I guess it doesn't count.
Yeah.
That one looks like a because you could say,
So this is just a prime example of what Alex was talking about this morning in terms of playing with the mathematics. It's really important to be playing around with this and to find out and to prove to yourself, your partner and the skeptic in the room, how many different ways there is to actually create your rectangular prisms. So far, I've got 6 over here. Does anyone think there's more than 6 ways? You think there's more than 6 ways? Okay. Okay. Do you want to explain why you think?
Yeah, well, originally we were just talking about, because we had a wondering, and our wondering was, did everyone originally start with just one layer, whereas we built up for our first one, and then we thought, well, what are the factors of 32? And use that notion of factors to then help construct what we had, and we thought, well, you can have 1 of 32, 2 of 16, 4 and 8 are all factors.
Yeah.
And you can manipulate that so you can multiply that out to the and then we were just talking about, well, if you've already worked that out, what would the next step be? And we were trying to think about how you can add in other areas of maths. We talk about multiplicative thinking. A lot of students have difficulty with that times as many. So if you said, if you had 3 times as many blocks as what you've got, what size would be, and then what would the area be?
Yeah, perfect. And the areas are exactly what we're one of the concepts we're focusing on here, because we were talking before about if we were to make so this shape over here, even though it was created somewhere around here, it was lying down. The dimensions were the same, but the orientation was different. So we could say that they are different, particularly if we're talking about if we're to then draw it onto a 2D piece of paper. But if we're talking about volume and we're talking about area, then the dimensions would be the same, right? So this is a really good way to get students to really become familiar with and understand volume and area really, really explicitly, even though this is not an explicit lesson. They're exploring and it's a problem-solving lesson. This is your explicit moment to stop and to talk about all the different ways you can make your rectangular prism.
We were just relating to the book that Marilyn talked about, that Imagine a City. If you said to kids, oh, you've got 32 blocks, we have to build 10 different buildings that look different.
Yeah.
Them doing it and then pitch that to the board.
Yeah. Yeah. Yeah.
And then a way to extend it as well too, what you could do is, it doesn't necessarily have to be a rectangular prism, how many ones can you make with it as well too, and then how that will get to the
Because you could just do one singular line of 32 as well. Yeah. All right. So just an extension onto that. So that one lesson could continue, because what you could do with that, and I've realised I'm talking a lot. So What you could do, my next step with this would be then to get them to draw them onto a piece of paper and then try different numbers. What about 24 cubes? What about 16 cubes? And what about if we use a odd number instead? Does that work? And have them draw it on, because this is your recording method, this is your work samples, this is your assessment as well.
So
Yeah.
you prefer them to actually have the task of drawing it rather than just photographing it and writing
Oh,
it?
photographing would be great as well.
Okay.
Yeah,
So
that'd be
there's
another
sometimes
element.
there's doing the isometric bit is its own
Another
element,
element,
particularly
yeah.
with funky shapes.
Yeah,
There's
definitely.
the inky block.
But then that's also a really great maths opportunity too, because I know one of the curriculum areas is transforming the 3D to the 2D and using your scale as well. So both are, yeah. So here's my next task for you. How many cubes would you need to build this rectangular prism without building it? And then my next question, because I can hear the answer already, how do you know? How did you see it? Do you want to say that out loud for me?
16 plus 16 plus 16.
Great.
8 by 2.
Yep. Anyone do it differently?
I just did 6 on the end and then multiplied that by how many across, there was 8 across.
Fantastic.
I went 3 times 8 times 2.
Yeah. Yep.
But I was doing the whole cross-eye thing. Is it 8 or is it 9?
Yeah. Yep.
Most of my time was spent making sure I counted correctly.
I actually looked at half and then doubled it.
Yes. Yep. And you could look at even the 3 layers as well. So if I wanted to paint the outside, including the bottom, how many square units do I need to paint? Off you go. Work that one out. And if you were to give this to students, this is where you'd say, you'd have the cubes there. Let them make it, let them build it, let them play.